हाँ है पेपर में याद start let us start
Okay, okay. Hmm.
चालू करूँ
होगा कर.
हम्म so hello viewers welcome to video geek series where we'll discuss the interesting topics to increase and enhance your knowledge so today by resuming the journey let us see that what the Dev has to say or what the topic that Dev has to discuss today. Let's start, Dev.
Yes. Thank you, Anil. So
Yeah,
today's topic is blockchain. I think we have done one video on blockchain, but I think it is not that video was not enough. So I have come up with a structured way as of now. So let me just share my screen.
yeah. We have discussed very basic introduction of blockchain, what it
Yes.
is, and the terminologies. So, is it that you are going to give a brief discussion on the blockchain?
No, just it will be in a structured way. It is the same, but you will see a different approach.
So, yeah, it will be very helpful.
Yes. So can you see the screen? I think
Yeah, yeah. I can see the
yes.
screen. You have opened the word.
So yes. So let me ask you. I think last time I asked you tried to give definition. So and then I have explained you in the video. So since you have seen the video, what do you think blockchain is now?
So, where previously I was not aware about it, but as we have discussed in previous video, the
Mm-hmm.
blockchain is a system of you can see a ledger system, but it is online,
Mm-hmm.
and there will be a network running on which the ledger or you can see the transaction will be set among all the
Mm.
participant or recipient.
With the
That's I
nodes.
can
Yes.
yeah that I can tell you.
Okay.
And the
Yes.
word you have said that the word blockchain you can break the word in block and chain. There is a chain of block which means the chain
Mm-hmm.
of transaction blocks. That's
Mm-hmm.
I think it if I've understood
Yes.
correctly.
Yes. So some of the keywords probably are missing, but very nice try. So this is the stuff we are going through today. So these six things we will be seeing today. Firstly, probably what is blockchain. So I want to uh, re-put the definition and the whole topic like in this manner. What is it? Then when it was first appeared, and structure of blockchain, applications and features, and I will rather keep application at last, features and types. Okay. So
Yeah.
what is it? So I have written something. I have written all this stuff in my note, so I will be reading that. So blockchain is the most popular type of distributed digital ledger technology, that is called as DLT, is basically
Yeah,
record keeping
distributed.
a ledger. Yes.
Yeah, DLT, which means
Yes,
distributed ledger
ledger
technology.
technology. Yes. So previously, what happened is all the ledgers were in the physical form, like in this books and stuff. But now it is digital. So they have renamed it to digital ledger technology because blockchain is based on that. So the ledger has become now digital. All the ledgers has become digital. So distributed digital ledger technology is basically record keeping a ledger but distributed. Now there are two things: distributed and digital. Digital, that means on our PCs, phones, everywhere, and distributed, that is the main part which makes it close to blockchain, hence resulting in a distributed digital ledger. So it was digital ledger technology, but if it is digital ledger technology, it does not make it blockchain. But if we add distributed to it, DDLT, or we can say distributed digital ledger, DDL. So this stuff
Yeah.
is blockchain. This is blockchain.
Yeah.
This is
So
just digital. But the main keyword here, it is digital. That makes it uh, the whole thing is based on blockchain. So yeah,
yeah.
you were saying something.
So digital is not whole, but it if it is distributed digital ledger technology, then
Yes,
it is a whole blockchain.
it is something that we are talking about blockchain. If someone is saying distributed digital ledger, then it has to be about blockchain. But if it's digital ledger, then it may or may not be about blockchain. The
Yeah,
keyword
got it.
behind blockchain is distributed. So I
Yeah,
think
yeah,
last time I have given example of that RBI is controlling, RBI is centrally controlling the currency. Let's say this paper is of 50 rupees. So none other than RBI can change that price, right? It is centrally
yeah,
controlling that uh, price, and that is centralization. But in blockchain, with help of blockchain, we can create such currencies that are distributed. Means all the nodes in the network can change anything, but all the nodes has to agree on a transaction. Then only the transaction will happen.
yeah.
Do you
So
get it?
that's why
Yes.
it is a distributed.
Yes. So distributed nature is, for example, if it is centralized, there is a point of failure. There is a कट कैमरा एंगल एडजस्ट करो जो
हाँ
बिकॉज
हाँ.
दिव्यराज सिंह सुनवा हैज एंगल पर नहीं
એ ઇથરનેટ ભરાવેલું છે.
શું
ઇથરનેટ ભરાયું છે.
શું કે છે હા બોલો
ઇથરનેટ
હા
લગાવેલું છે
ઇથરનેટ
એમ.
પર આવ્યું છે હા હા
હા હા. પેલું કેમેરામાં આંગળી નાખી દે એટલે ખબર
આંગળી
પડે. એટલે એમ
અચ્છા
પેલું
કટ
ખબર પડે કે ડિસ્ટર્બન્સ હતું.
કટ થઈ ગયું થઈ જવું જોઈએ फिर दोबारा कैसे होगा ट्राइपॉड लेना पड़ेगा રેડી છે ને થઈ ગયું લગભગ
ગુડ ગુડ. હીરો દેખાય છે.
રેડી ને તો
હા રે.
starting.
હમ.
So now that you have, I have explained what is it. Let's see when it appeared, when it first appeared. So the technology came into existence with inception of cryptocurrency, Bitcoin, since 2008 by Nakamoto. So if you are interested in the history of blockchain, you will first hear this person's name, Nakamoto. He was, I think, working on an e-cash system to. It was a solution for for a problem to double spending problem in a decentralized, trustless environment. So I think we are talking about trust in the RBI. We have to trust RBI. if we that is a even if we are doing transaction, for example, you are buying something from Amazon, you are trusting Amazon, so that is a third party in a centralized manner. But if it is decentralized, all the other nodes will make sure that the transaction should occur, then only the transaction will happen. So you don't have to trust any third parties
Oh,
here.
yeah. So
Okay.
if we can put it this way, like if we are having some transaction and your friend, which is acting as a third party,
Hmm.
so I can say that you and your friend has some contract going on between two of you, and you are trying to betray me by saying that
Hmm. Yes.
you have
Yes,
had
exactly.
transaction, right?
Yes.
So if
Yes,
there
exactly,
is
Sandeep.
more such notes, so the thing which can happen between three of us cannot happen, right?
Yes. All the person should agree, then only it should happen. So yes, he was working on some paper. He was working on some white paper thing. I exactly don't know what it means, but he was researching something on this. Then the he invented blockchain from cryptocurrency basically. So yes, uh, so this is in 2008, right? The blockchain stuff. But before 2008, it does not mean that there was no concept of decentralized and stuff like that. I have written that, however, underlying technologies slash concepts such as Merkle tree, hashing, digital signature, P2P networking, and distributed storage existed much before blockchain. So in 2008 it appeared, but underlying concepts were already there. So the third thing we are going to see is its structure. Hmm, Wait a minute. Okay.
Tomorrow when we meet, I want to see your notes.
Yes, I have PDF. Uh, PDF in the this part of side. Yes, here it is.
I have seen your folder structure, and I think probably in future we are
Hmm.
going to see the content of Solidity also.
Yeah.
Yeah,
So
yeah,
let's just do this in this way. Let's say this video. So structure, we will see Bitcoin block to study the structure of blockchain. So Bitcoin is implementation of blockchain basically, as you can see. It is divided into two parts, header and body, conceptually. Header structure of Bitcoin block contains 6 fields of metadata. Its size is 80 bytes. So this size is not fixed because we are talking about Bitcoin, right? So this Bitcoin blockchain's header is of size 80 bytes. If you take Ethereum, maybe it is different. So specifically here for Bitcoin, it is 80 bytes. It is not fixed. And body part is variable size. It has to store a set of transactions and a transaction counter. Its size varies from 250 to 500 bytes. Okay. So the first block of any blockchain is named as Genesis block. So first block is called as Genesis block basically. It has no
yeah.
parent block to point at. So the first block is Genesis block, and the second block, that is called as first block, and then second, and so on. So as we have seen that header has 6 fields, so these are the 6 fields. Version of that blockchain, previous block hash, Merkle tree root hash, timestamp, difficulty, and nonce. So his difficulty is basically about mining stuff, that how hard it is to find a new block. such as these conditions. This you can see block has less than or equal to target has. If the target has, if this condition satisfies, the mining will be successful. So that difficulty is this, and it uses proof of work consensus algorithm. And if
Yeah,
we talk about
I have
body, yes,
I have seen the term. I have known this terminologies,
which one?
numerical tree and
Yes.
a consensus algorithm and known.
Mhm.
Yeah,
Okay. So the sorry, block body contains finite number of valid transaction and a counter, as we have seen. It is not a standard body, as we know. It is of Bitcoin, not particularly. So there is nothing centralized there, nothing fixed that you should be using. Uh, block body has this number of bytes. It depends, right? How you have implement. You can make your own blockchain product like Bitcoin, like you can make it. It is Bitcoin's block body. It can contain smart contracts also. So now that we are done with structure, let's do features. So it probably offers many features that make it usable in many applications. So immunity, decentralization, transparency between transactions, pseudonymity, non-repudiation, fast processing, low cost, provenance, audibility, availability, automation. This. So let's see one by one. Immunity. So this feature can be definition of blockchain too. It is a append only ledger. The way blocks are created using cryptographic techniques chained together logically using hash based chain, and they do transaction. So uh, in many definitions, this they use this append only ledger. They mention this feature and they make definition of it. So this feature is very important. Decentralized. Again, you can make definition of blockchain from these two. Not governed by a central authority, no single point of failure, and all other properties acquired by decentralized also leads to disintermediation. Disintermediation. I need to look up this term. I don't know this term. So if you are using Google Pay, you need to trust Google Pay. You have to trust Google Pay that it won't be failed. There is a single point of failure. If it fails, you cannot do transaction between you and your friend, right?
yes,
But if it decentralized, you don't have any single point of failure. For example, you have a problem and you cannot do a transaction between you and your friend. Other people on the network can do already. But if Google Pay fails, right, all the people cannot do transaction. So that is very good point of decentralization. Then transparency. As we know that if you want to do transaction, every other node on the blockchain should agree on the transaction. Then only the transaction will happen. So that is transparency. Transparency in centralized system have been major issue. Blockchain allows solution to this problem by allowing the members of peer-to-peer network to read the transaction data and other activities, hence making it transparent. So here you're seeing that it reads the data, it reads the transaction and data. So you have maybe doubt that if it is readable by others, then it is not secure, right? But they
yeah,
cannot see every information. Like for example, I am trading 50 rupees with you. So what other person will see is that there is that this is a valid block. There is a transaction happening from A to B at this time, but exact data, how much money has been deducted from my bank account, how much amount of transaction was made, this information may or may not be available, may or may not be readable by others. So just they can see the transactions are happening, but not what inside of them are happening. Or they are just even if they are able to crack into them, it is just a cipher text. They cannot debug it. The next feature is
Yeah.
pseudonymity, that is anonymous. As you can see, transparency, there is transparency, and I have told that you can make any transaction without revealing your identity. This feature of blockchain allows user to participate and play different roles without need to disclose their real life identities. So if you are using Amazon, you have to give your phone number, and you have to give a, give your name and stuff like that, and other people can also see it. So a seller can see that this person is buying. But what blockchain has done is you can remain anonymous and still do the transaction. It is done by assigning unique digital identity to every entity in blockchainized system. Okay. So then there is non-repudiation, similar to contract. So basically contract, what we have, the two persons agree on something to happen. The goal of non-repudiation is to generate, gather, and preserve the evidences of performed digital activities. So they just store that this transaction has happened. Like there is an agreement between two. For example, we are doing a transaction, then there is a that uh, I am sending the data, you are receiving, this is the amount, stuff like that is taken care by non-repudiation of blockchain. This can be done using asymmetric encryption and digital signature. So there is digital signature too. uh, uh, in my side, I will sign, and this is my public and private key. And on your side, I think I will explain that on Equipment, no? Yes. So next feature is fast processing. With elimination of intermediaries, that is decentralized and distributed technology makes all the processing faster. So there is no Amazon, no Google Pay, just sender and receiver, just you and me. The transaction is happening, so it will be probably faster. I don't have to wait. I don't have to wait for Amazon to give me the confirmation and stuff like that. It's just so fast and low cost. Since all third parties again are eliminated, the overall cost would probably be reduced. Then there is provenance history. This feature let you backtrack various state changes or alternations that happened from current point to inception. So you can track back to what happened in the transaction. It is basically transaction history. It is helpful in supply chain management, land record registration, and stuff like that. Then auditability. Every transaction in the network that is happening is validated by all other nodes present in the blockchainized environment. Availability. Decentralization and distributed nature of blockchain gives availability to this feature. Yes, it is as simple as that. And automation. It facilitates automation by using smart contracts, which are self-executing computer programs emulating terms and conditions of an agreement, useful in decentralized apps. So this is important. This is currently in trend that you can write smart contracts that can run on their own using some programming languages. So currently, uh, this has been used for writing smart contract in Ethereum. We will see this later.
Yeah.
So the next one would be types of blockchain. So there is three types of blockchain: public blockchain and private blockchain and consortium blockchain. Okay. So on the public blockchain, it is an open, unrestricted, and permissionless distributed ledger system. Example of public blockchain are Bitcoin and Ethereum. So Bitcoin and Ethereum are public blockchain. It makes
Yeah,
blockchain
because
highly transparent. What?
because blockchain is accessible by everyone, so
Yes.
we can easily relate that it is a public blockchain, right?
Yes. So since it is public, there will be less privacy. You can see probably slow convergence. I don't know the meaning. More prone to attacks and unregulated. So because more information will be revealed, probably there is chance for attack. You are get being attacked. Then there is a private blockchain. So currently,
But
because it is
Dev,
public, yeah. Hmm.
you have said that in public blockchain there is a chance of attack, but
Yes.
recent in you can see recent time we have not seen any attacks happened on such
Yes,
blockchain or such.
because
Yeah,
it has not been implemented yet. Blockchain is still in its starting phase. It has not been implemented entirely. That's why.
yeah.
If it is,
So there is,
for example, voting machine, there is this voting is very complex. But electronic voting machine, we should implement blockchain, but it is not yet implemented.
so you are saying that there is less number of people, so there may not be a chance of attack right now, but as
Yes.
it will
And
explode by many of
it
people
goes to
in future.
scale. When it goes to scale, then that should happen. So
Okay, okay.
kind of as a system, it may or may not be attackable, but inside, for example, if you are outside of the network, you may or may not be able to do the proper attack. Why? Because it is decentralized. But if you are inside, you can trick all the nodes to agree on your transaction. That is this stuff. If you're outside, blockchain itself is secure, but in public blockchain, if you are inside that network, then it gives chance to attack, because you can maybe trick all the nodes that this transaction is right. You have to agree to this transaction. So that way. And in
Okay,
private
okay.
blockchain, opposite to public blockchain, closed, restricted, permission blockchain type, accessibility of network is different. Uh, for example, this is a tree type of structure for the nodes. There is a higher authority than uh, people belonging under them may or may not be able to read the data or communicate with higher authority at any time. So they can implement private blockchain there. So examples are Corda and Hyperledger. It gives higher throughput, low latency. So probably because of less information being transmitted, it will give high speed than public blockchain. It is more reliable because there is less complexity than private blockchain. Okay.
Hello. Hello. Welcome again. The recording is already started. You
Mhm.
can resume your talk.
Voice is audible.
Yeah, it is.
Okay, I need to share the screen again. In fact, I need to rejoin. Screen is visible? Yes, it is.
Uh,
So the third type is consortium blockchain. All the members in the consortium here the rights to write and verify the data on blockchain. It is also permission blockchain, only authorized node from. So basically, it is a mixture of private and public blockchain. It is also a permission blockchain, only authorized node from each member are allowed to participate in the mining process, only authorized. So in private, no one can access the higher authority, but here only authorized nodes can access. So it is kind of hybrid version of private and public blockchain. No fee required, distribution of power, faster accomplishment of consensus and synchronization, high throughput,
your mic
etc.
was off.
Yes. Okay. So now types are over.
You are not
So the
audible
last
right
part
now,
is
Dev.
wait. Your camera is on. Hello, Harshil.
You are audible.
Harshil.
એને મેં એડ કર્યો કેમેરો બંધ કરે
કેમેરો બંધ કર. એને સંભળાય જ છે. જોજો. So let's talk about smart contracts without wasting time. The concept was introduced in 1990s. So before blockchain, with a set of promises in digital form to database protocols that should be followed to fulfill what is promised. So as you can see, contracts, smart contracts, the two parties had to agree on the what is being said. It is like SRS, software specification requirement. Its aim is to partially or fully execute. Its aim is to partially or fully getting executed without human intervention. Automatic scripts that should be running on your computer that checks or that does some calculation on decentralized app. Blockchain network executes the contract on its own. This gives smart contracts decentralized operation, immutability, and elimination of third party. So before blockchain was not invented, there were these features of blockchain were not there: decentralization, immutability, and the main important elimination of third party and autonomous execution, transparency, accuracy, and speed. So after blockchain, we came to know that we can implement smart contracts with blockchain. Will add on these features. So yeah, it comes up with this bunch of features. Example of blockchain platforms supporting smart contracts are Ethereum, Hyperledger, Fabric, Corda, Stellar, and EOS. You can see the mixture of private and public blockchain here. Ethereum is public, Hyperledger is private, Corda is also private, as you have seen. Smart contract researches are of two types: development and evolution. So this it. So now let's move to the implementation part. That is Solidity. So first of all, it is a language. It is a programming language, object-oriented programming language used to write smart contracts for Ethereum. That is based on blockchain. That is based on public blockchain. So you can write, if you want to write smart contracts, scripts that run on their own without human intervention. You would need to use Solidity to write smart contracts on Ethereum. So let's see what Wikipedia is saying. It is an object-oriented programming language for implementing smart contracts on various blockchain platforms, most notably Ethereum. So Ethereum is like, if it is Solidity, you have to use Ethereum. All the people are using that. So it is an object oriented like C++. So Solidity is curly bracket like designed to target the Ethereum virtual machine. So Ethereum virtual machine, what is it? So whatever code you write on Solidity, it will be processed by Ethereum virtual machine. It will be understood by that EVM. It is influenced by C++, Python, and JavaScript. Right. I will put this link of documentation of Solidity. This is the latest version of Solidity. Right. So it is. This is also important. It is statically typed. So you need to give uh, data type uh, forcefully. And one of the thing about this is in C++, for example, you declare a variable, it gets stored, but normally, right? But in Solidity, if you write for example, int a is equal to 5, it is considered as a transaction, and it is stored like as if it was it will all the features of blockchain, all the properties of blockchain will be applied to that transaction. So that way it is getting stored because it is a blockchain based application, right? So if you need to code this, let's say you want to write a smart contract. So this is a remix Ethereum IDE, right? You can write, you can see the folder structure. There are contracts, sample contracts given here, storage, owner, ballot, so several problems. So if you remember here in the history of blockchain, I have told that on the first appearance of blockchain, there was a problem of storage, right? Double speeding problem, I think. Uh, so first line of code, this is, so this is a license. You have to write this. If you do not write this, it won't work. Then there is this pragma, that is version of Solidity, how which version of blockchain, which version of Solidity it is able to compile, which other programmers can understand what version they have to install and stuff like that. So this is a multi-line comment you can see. Now for writing contract, you there is a contract keyword, then name of the contract,
You are muted.
yes. So uh, you would write contract name, then there are, yes, you can write int number 2, right? Number 2, then after for practices you can write this, but for the from the developer and optimization point of view, for example, you know that this variable is going to be used for storing small values only, so you will use the smaller version, yeah. So there is 256, then I think another version too. Then you can write functions like this, and some of the libraries provide, so let's say you want to print something, so some of the libraries provide simple console.log too. So let's not go into deep into that. So let's say you have written this code, right, and you need to compile it from here. I think, yeah, yes, this one. So you would click on compile this code. So it is compiling. It has been successfully compiled. You can see this icon, and now you can see that we have two integers, right? But this code is written to store this number integer, right? So we need to deploy. So this is my balance, right? uh Wait a minute. So these are my balances. I can have and this address and this balance. So how it works? So if you do one transaction, there is a gas that is being used. So you can see this gas. Initially it is this much, and this is my balance. So if you store these variables, if you call this function, the specific amount of gas and Ethereum from your account will be deducted. So let's deploy this. It has been successfully deployed. Now let's say we want to store 25, then it will retrieve. I think it is designed to like write the function. So, but you can see that the amount has been deducted from my ether. Initially it was 100 ether, right? But now the some amount has been used, right? So there is a list of transaction you can save, and yes, so there is a lot to explore in the Solidity part. Yes. So this is basically it about Solidity overview. I will go much detail. I would like to go in much detail about Solidity in the next upcoming videos. So yes, this was it. We have gone one more step ahead into the blockchain, and we will try to write a real life problem and try to see what solution is there for this problem in real world in the next videos. So yeah, any questions?
No, I think I'd like to watch some of more practical stuff that you have shown
Yes.
in last, I think, 5 minutes. But
Yes.
yeah, probably this is one more step ahead from
Yes.
comparing to last video. And
Mm-hmm.